Hello everybody. Let's discuss another interesting question. What we are given is a rectangle KBPO with dimensions 10 and 5 like this. And we also have a square OACB like this. OC is a diagonal obviously, and we have a triangle being completed and a perpendicular as shown in the diagram. Okay? As shown in the diagram. And what we need to do is we need to find the area of area of quadrilateral AQRS, the shaded region. Okay, the shaded region. Now, working with this original diagram, it's a little tedious. Okay, it's a little tedious. So what I do is, since this is a rectangle, this side is 10 because this side is 10, and this side is 5. So because this side is 5. So now I will get rid of this part of the diagram. Okay, get rid of this part of the diagram, and I'm going to work with this square with whatever that is inside it. Okay, I'm going to work with this square. For doing that, I'm going to reposition this square like this. Also, I'm going to take the positive x-axis along OA and the positive y-axis along OB. Okay, we'll come back to that later on. I'll explain why, or should I say, you'll know why I used coordinate systems. Okay, all right. Now let's see. This is a right angle triangle. So by Pythagoras theorem, we can say is the length OB is equal to will be equal to square root of 5 squared is 10 squared, which is I guess 125, and 5 root over of 5. Okay, so the length OB is 5 root over of 5, and since this is a square, OA is equal to 5 root over of 5, AC is equal to 5 root over of 5, and BC is equal to 5 root over of 5. Okay, this is 5 root over of 5, like this. Okay, now let's see. Where's the other marker? Yeah, it's right here. Let's call this angle alpha. Then this angle will be 90 degrees minus alpha. As a result, this angle will be alpha. Right? Okay. So let's see. Now from this triangle OBP, let's say from triangle OBP, what do we get is sine alpha is equal to 5 over 5 root 5. Okay, 5 over 5 root 5. So this is basically equal to 1 root over of 5. Okay. Next. So sine alpha. Now from triangle OPQ, sine alpha is equal to OQ. Sine alpha is equal to OQ over the hypotenuse is 10. So 10 is equal to 1 over square root of 5. So what we get is OQ is equal to this is 20 into 5, I guess. 20 into 5. No, 2 into 5. 10 means 2 into 5, square root of 5. So this is 2 root over 5. Okay, this length here, this is 2 root over 5, as a result of which this is 3 root over 5, because OB is equal to OA is equal to BC is equal to AC, being sides of a square. Okay, that's it. Now let's see. Now let's calculate the height PQ of triangle OAP. Sorry. Let's clean the board a little bit. Okay. So what we have is a right angle triangle. Okay. This triangle. It's O, it's P, it's Q, and okay, this is 10, this is 2 root 5. So by Pythagoras theorem, PQ is equal to 10 squared minus 2 root over 5 squared. This is equal to 100 minus 20, which is 80. So this is equal to 4 root 5. Okay, this length is equal to 4 root over 5. So this blue length is oh my god, 4 root over 5. Okay, now let's see. First the red one. Okay, here it is. We have something like this. And here's the point R. Okay, and since this OC is a diagonal of a square, this angle is 45 degrees. So this angle is 45 degrees. Okay, this angle is 45 degrees. And so this side OQ is equal to QR. So OQ is equal to QR. So this is 2 root over 5. This length is 2 root over 5. And since this is 4 root over 5, this length is also 2 root over 5. This length is also 2 root over 5. As a result of which, we can conclude that the point R is the midpoint of the line segment PQ. Okay, line segment PQ. So let me write it like this. These two parts are equal, and this is equal to 2 root over 5. So this is 2 root 5, 2 root 5, and the whole length is 4 root 5. Okay? All right. Now, yeah, I think this is done. Okay. Now, what we do is we draw a line . We draw a line RT parallel to QA like this. Yeah, parallel to QA like this. And let's see. Since this is a midpoint, R is the midpoint of the side PQ. Okay, R is the midpoint of the side PQ, and since RT is parallel to QA, from the midpoint theorem, what we can say is that the length RT is equal to half of QA. So RT is equal to 1 by 2 times QA. So this is equal to 3 root over of 5 by 2. Okay, this length is this length is 3 root over 5 by 2. Now let's calculate the area of this trapezium. We have a trapezium right here. Okay, we have a trapezium. The trapezium is this trapezium. This is Q, this is R, this is T, and this is A. These two sides are parallel, and this length is 2 root over of 5. This is 3 root over of 5, and this is half of 3 root over of 5, which means 3 root over of 5 by 2. We know that the area of a trapezium is given by 1 by 2 times the height into the sum of parallel sides. Okay, the sum of parallel sides. So trapezium AQRT is equal to half times the height is 2 root 5 here, 2 root 5 times the sum of parallel sides is 3 root 5 plus 3 root 5 by 2, 3 root 5 plus 3 root 5 by 2. We can cancel this 2 with this 2. What we have is root 5 times 3 root 5 is a common factor, 3 root 5 times 1 plus 1 by 2. Okay, this is 5 into 3 into, this is 3 by 2. So trapezium AQRT is equal to 45 by 2. Okay, so this area of this quadrilateral, this trapezium, is 45 by 2. Is 45 by 2. Now, to find the required area, what we need is the area of triangle RST. Remember? You remember anything? I've introduced coordinate system, okay? Positive x-axis, positive y-axis. Now we're going to use it. Let's see. We know the base. Okay, we can take this side as a base for this triangle RST. So what we would need is its corresponding height, isn't it? We need this length, and this length can be obtained as a difference of this entire length and this length. This length is nothing but 2 root 5. Okay, this is this, if this is 2 root 5, this is 2 root 5. Okay, so all we need is this length. Now, since we are on the positive quadrant, by positive quadrant I mean the first quadrant, okay, let's see. S dash. OS dash is the x coordinate of the point S, and S dash is the y coordinate of S, because we're in the first quadrant. Okay, so if we can find the coordinates of this point, we're basically done. Okay, we're basically done. So to find the coordinates of this point S, we need to solve, it's an intersection of this line and this line. So we need to solve the system which consists of the equation to the line OC and the equation to the line AP. Okay. Now, since this is a diagonal of a square positioned in a standard way, the equation of this line OC is y equal to x. This is y equal to x. Okay. Now to find the equation of AP, we need the coordinates of A and P. Coordinates of A, let's see. The length OA is 5 root 5. So its coordinates are 5 root over 5 comma 0. Okay. So let's see. This is 2 root 5 and this is 4 root 5. So the coordinates of P are 2 root 5 and 4 root 5. Now to find the equation of AP, we can use the 2-point form of the equation, which is nothing but y minus y1 is equal to y2 minus y1 by x2 minus x1 times x minus x1. X and y, give the coordinates of any point on the line. Okay, and we can consider, if we consider this as x1 y1, then this is x2 y2. So the equation corresponds to, this equation becomes y minus y1 is 0, so y equals to y2 minus y1 means 4 root over 5. x2 minus x1 means minus 3 root over 5. X minus x1 means 5 root over 5. Okay? 5 root over 5. Okay. We can cancel these out. So this is basically the equation of, equation of AP, and to solve, and we need to solve this and the equation along. Okay, we need to solve the equations this and y equal to x, and we simply need the y coordinate. Okay, we simply need the y coordinate, so we solve for y. Okay, we solve for y, and to solve this equation for y, simply put x equal to y, and we'll obtain y equals to minus 4 by 3 y minus 5 root over 5. This means we have 7 by 3y, okay, 7 by 3y plus 1 plus 4 by 3y, okay, and minus times minus means plus, so 4 times 5 means 20 root over 5 by 3. You can cancel this 3 with this 3, and y will be equal to 20 root over 5 by 7. So the y coordinate of this point S is 20 root over 5 by 7. So this whole length SS dash, so SS dash is equal to 20 root over 5 by 7. And so what we need is SS double dash, isn't it? SS double dash, and SS double dash, SS double dash is equal to SS dash, SS dash, SS dash minus S dash S double dash, S dash S double dash. Okay, SS dash means 20 root over 5 over 7 minus this length S dash S double dash is equal to 2 root over of 5 because we have a rectangle over here. 90, 90, 90 means this is also 90. Okay, so 2 root over of 5. This will be equal to 20 minus 14 means 6 root over of 5 upon 7. Okay, so let me clean the board a little bit. Let me clean the board a little bit. Okay, now, yeah. R S T S double dash. This length was 3 root 5 by 2, and this length we just calculated to be 6 root over 5 by 7. So the area of triangle RST is equal to 1 by 2 times 3 root 5 by 2 times 6 root over of 5 by 7. 6 root over of 5 by 7. So this is 3. What we have is 45 by 14. 45 by 14. Okay, just simple calculation. Now we're basically done. All we need to do is add these two areas. Okay, these two areas. We found the area of this part and this part. So required area. The required area is the required area is this plus this, isn't it? This trapezium plus this triangle. So 45 by 2 plus 45 by 14, which is equal to 45 by 14 times 1 plus 7. 1 plus 7. This is 8, so 4 and 7 means 45 times 4 means 180 over 7. Right. That's the required area. Okay. Now there can be many other ways to solve this problem. I found this one the easiest. I came up with this one. Okay. I just came up with this one. You can deal everything with coordinates. I didn't deal everything using the coordinate approach. You can do it using the coordinate approach, but it will be you will need to do a lot of calculations. That's all. And you can do it without using the coordinate systems at all, but that'll be a little more tedious, I guess. Okay, all right, thanks for watching and take care, everybody.